Good morning, everybody, and welcome to the CDIA Maths tutorials. Today we've got two sessions. The first session is going to be delivered by Suzanne O'Callaghan on paper 1 questions in the Leaving Cert Maths exam.
Thanks, Eamon. Good morning, all. So this morning we're going to discuss paper 1 exam topics, and it's just some guidelines on the kind of topics that will come up in your paper 1. The complex numbers, algebra, functions, induction, logs, sequences and series, differentiation, integration, trapezoidal rule, financial maths, rates of change, and average rates of change. So just a thing to note here, they are guidelines. What has been evident in the last number of years is that some topics appear on paper 2 also, not as a standalone topic, but as a section that might be part B or C that you need to use the information from one of these topics to solve another question. So you basically need to be prepared going into both exam papers. You need to have your course completed in full. So today's exam topics, we're going to look at basically taking you through a full exam paper. And in section A, question 1 in this paper is algebra, logs, and induction. Second question is simultaneous equations and functions. Third question is dealing with roots of equations. Question 4, complex numbers, polar form, and de Moivre's theorem. Question 5, functions, differentiation. Question 6 is integration and the area under the curve. Question 7 is log and exponential functions. Question 8 and 9, I'm not sure if we'll get to, it depends. Question 8, financial maths, and question 9 is acceleration and rates of change. So this is question 1. I basically worked through it on the screen. If you have any questions, please put it into the chat, and Eamon will let me know, and he'll interrupt the lecture. And that's fine, because asking questions helps me to understand what parts of the solution you don't understand, and you'll also probably find that other people have the same query, so don't be afraid to ask the questions. So the first part of the question is solve 2x squared minus 11x plus 15. The solution to this would be fairly straightforward. You should be very practiced at these. So you're going to have 2x and x. You have a minus and a plus in the equation. The last one is a positive, which means there has to be 2 minuses. And the last items, the last numbers in each of the brackets are going to be factors of 15. So we have 5 and we have 3. So that leads us to then, for the first bracket, 2x minus 5 is equal to 0. 2x is equal to 5, so x is equal to 5 over 2. Second bracket, we have x minus 3 is equal to 0, x is equal to 3. So they're the solutions for that part of the question. Now, the next part of the question says, hence or otherwise, solve 2 times 1 over t squared, all to be squared, minus 11 times 1 over t squared plus 15 is equal to 0. So there's a clue here when they say hence. It means something in the first part of the question will help you solve this. So if you look at this equation here and look back at the equation that you've just solved, there are similarities. If we write it underneath it here, 2x squared minus 11x plus 15 is equal to 0. You see they're identical, bar one thing, which is that where x is, 1 over t squared is. So if you let x equal to 1 over t squared, you have already solved this equation in terms of x. And the values you found were that x is equal to 5 over 2. And you also found that x was equal to 3. So in that case, you can let 1 over t squared equals 5 over 2. So we cross multiply and we get 5t squared is equal to 2. T squared is equal to 2 over 5. And t is equal to here, square root 2 over 5, which happens to be 0.63, because they asked you for the answer in 2 decimal places, correct 2 decimal places. So again, we have 1 over t squared is equal to 3. So cross multiply again, just once this time. So that gives us 3t squared is equal to 1. So t squared is equal to 1 over 3, which means that t is equal to the square root of 1 over 3, which happens to be 0.58. So they're the solutions to your question. So if you have any questions, please send them through in chat. I can go back over any part of that if you wish. Now we have a next question, which is show by induction. And a lot of people tend to avoid questions like this, but the induction question, I tell all my growing students, is that this is a dead cert question, in the sense that there's a set method for solving it. If you follow that method, you'll get the bulk of the marks. So for induction, to prove by induction, no matter what the format of the question is, you will always follow these 3 rules. Firstly, you prove that the equation is true for n is equal to 1. Secondly, you assume that it's true for n is equal to k. And thirdly, you then prove that it's true for n is equal to k plus 1. So for part 1, our formula is n into n plus 1 times 2n plus 1. And the question is, show by induction that n times n plus 1 times 2n plus 1 is divisible by 6 for n is a natural number. So we're proving it's true for n is equal to 1. Substitute in 1 everywhere there's an n. 1 plus 1. Into 1 plus 1 times 2 times 1 plus 1. And the answer to that is 6. And yes, it is divisible by 6. That's all you need to show. So you've proven that it is divisible by 6. Part 2 is assume that it's true for n is equal to k. So everywhere there's an n, we're going to put in a k. So we're going to get k times k plus 1 times 2k plus 1. And we're assuming that it's true. And we're assuming that it's divisible by 6. So let's expand that out. That gives us k squared plus k times 2k plus 1. And we're going to let that equal to 6a. And the reason we pick a is 6a is that we're basically saying, in order for it to assume it, that 6 times any number, a can be any number, that of course it is divisible by 6. So we let it equal to 6a. And that generates 2k cubed plus 3k squared plus k is equal to 6a. And we're assuming that this is true, which means we can use this in the next step, because we've made an assumption that it's true. Right. So now for our next part, we have to prove that it's true for n is equal to k plus 1. So we're going to have k plus 1 times k plus 1 plus 1. Apologies, I should write that again. K plus 1 times K plus 1 plus 1. And in the last bracket, it's 2 times K plus 1 plus 1. Okay, we multiply all that out. So that's going to give us K plus 1 times K plus 2 times K plus times 2K plus 3. Multiply the first bracket, the first two, these two here together, we'll get K squared plus 2K plus K plus 2. And all of that is by 2K plus 3. That gives us, I wrote something down here, 2K. Yes, I'm going to multiply it all out now. And it's going to give us 2K cubed plus 3K squared plus K plus 6K squared plus 12K plus 6. We've multiplied all that out now. What we should remember is that if you look at this part here and come down to part 2, we've already assumed that 2K cubed plus 3K squared plus K is equal to 6A, which means we can substitute in 6A in here for that part, and we're left with 6K squared plus 12K plus 6. Now remember, what we're trying to prove is that this is divisible by 6. And if you look at it straight across, the common denominator certainly is 6. You just need to tidy it up a bit. So that's 6A plus 6 times K squared plus 2K plus 1. Tidy it up further, we take out 6 here. It gives us A plus K squared plus 2K plus 1. And is that divisible by 6? Yes, it is, because everything that's in the bracket is multiplied by 6, which means it is divisible by 6. 6. That's Q, E, T. So these questions come up quite a lot. Show by induction that a certain formula is divisible by 6 or by 7. So it's the very same method you use. And something I want to explain to you as well is that I went back and had a look at the marking scheme. And this is what's really interesting about a question like this. Just write it in red. So if you had got to, let me see, for part 1, if you had just got to here. So this is a 15-mark question. You would have 4 marks. If you had just got to here, get 7 marks. Now you're at 11 out of 15. Oh no, sorry, this is cumulative. You'd have reached 7. You'd be getting 7. And if you got to part of 3, in other words, anywhere somewhere before you've actually finalized it, to part of 3, you would have reached 11 marks. So even if you didn't know how to solve it at the end, and it happens sometimes, it can be a bit tricky at the end, you're not sure how to clarify your proof, you would still get 11 out of 15 marks. That to me is pretty much a dead cert question, because once you understand the 3 steps that you need to take, you have them memorized, you practice a few different types of induction questions, well, that's it. You're guaranteed. It's a really, really good question to be able to mark down and say, yeah, that's a definite for me. So we'll go on to question 2, which is simultaneous equations. And at Leaving Cert level, they're just a little bit more complicated. And you have your 3 equations. So the first step you do is, so we'll say this is equation 1, this is equation 2, and this is equation 3. So your first step would be to take 3x plus 2y minus 4z is equal to 12. That's your equation 1. And we're going to take equation 3, but we're going to multiply it by 3 in order to get a matchup. So we have a minus x there, so it's going to be minus 3x. It's going to, it's going to be plus 12y plus 15z is equal to minus 48. Draw a line under them. Now, as it happens, we're cancelling out the 3 x's. So the top one is a plus, the bottom one is a minus, so there's no need to change signs. So they automatically cancel when you add those two equations together. And we have 14y, we have 15z minus 4z, which is 11z. And we have minus 48 plus 12, and that gives us minus 36. So that's going to give us equation number 4. For our next step, we're going to take equation number 1. We're going to multiply it by 3 this time. So that's going to give us 9x plus 6y minus 12z is equal to 36. And to match with that, we're going to take equation 2. We're going to multiply it by 6. And that's going to give us 9x minus 10y plus 12z is equal to 4. So just to go back up to equation 2, why did I multiply it by 6? Well, normally if you had a fraction under, if you had a number under the line, in order to get rid of that, you'd multiply across by that number. So if there was only 3x over 2, if that was the only fraction in that equation, you'd multiply across by 2, and that would get rid of your fraction under the line. However, you have 2 different fractions. You have halves and you have thirds. So the easiest thing is to multiply by 6. So if you multiply 2 by 3, that will give you 6. You multiply by 6, that will certainly get rid of both of those from under the line. And that gives us this equation down here. So we want to cancel the 9x's. However, they're both the same sign. So we have to change the sign of the below to negative, which means we then have to change the sign of everything across that line. So now we have cancellation there, and we have 6y and 10y is 16y. We have 12z, so we have minus 12z minus 12z, which is minus 24z. And we have, actually, I think I made a mistake here. This should be plus 36. So I have 36 minus 4 here, which gives us 32. And this has now become our 5th equation. I'll go up here for this one. So our next step, so we have now excluded x from both those equations, from equation 4 and equation 5. So we could go straight into resolving those straight away. And we'll move it up here. So for equation 4, we're going to have to multiply it by 16. And that's going to give us 224y plus 176z is equal to minus 576. And for equation 5, we have to multiply it by minus 14. And that will give us minus 224y plus 336z is equal to minus 448. Cancel, and we're left with 512z is equal to minus 1024. And that gives us z is equal to minus 2. So for the rest then, you just substitute in your z. And I would substitute z back into one of these equations here, because they only have 2 variables in them. They have z and y. So if you do that, you solve for y. So that would give you y is equal to minus 1, and that would give you x. We use that then to substitute back into one of the other equations, and that will solve for x. I'm not going to do that now because it would take up valuable time, and it's something you should be well able to do at this point. Okay, so again, any questions, come back to me. I'll go back through it. So our next part is graph the function f of x is equal to the modulus of x plus 3 and g of x is equal to 4. Right. So we have g of x. Let's have a look at g of x equal to 4 first. That's our easiest. So g of x is equal to 4. I mean, that's the equivalent of saying y is equal to 4. This is the equivalent of saying y is equal to the modulus of x plus 3. So where would we see y is equal to 4? So that means that every point on this graph, y is always equal to 4. So y is always equal to 4 here, 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 everywhere, all along that. So that's your graph, y is equal to 4. That's the line. Next one is the graph of the modulus of x plus 3. So what does the modulus mean? It basically means that anytime you get a negative value inside those modulus lines, the modulus converts it to positive. So we'll give you, for instance, let's start plotting some of this graph. So when x is equal to 0, if you substitute x is equal to 0, y is equal to positive 3. X is equal to 1, y is equal to 4. Now let's go to the negative ones. X is equal to minus 1, y again is equal to positive 2. If x is equal to minus 3, we get 0 in there, y is equal to 0. If x is equal to minus 4, that's going to give us y is equal to minus 4 plus 3 is equal to the modulus of minus 1. And the modulus means that your value is 1. So y is equal to 1. I'm going to do it for x is equal to minus 7. Let's see what happens here. So when x is equal to minus 7, we have minus 7 plus 3 is equal to modulus of minus 4. That's equal to 4. Y is equal to 4. So let's start plotting those. So when we have x equal to 0, y is equal to 3. So that's what's there. When x is equal to 1, y is equal to 4. Y is equal to 4. When x is equal to minus 1, y is equal to 2. When x is equal to minus 3, y is equal to 0. When x is equal to minus 4, y is equal to 1. And when x is equal to, let's go way out to minus 7, y is equal to 4. Okay, so that's the graph of y is equal to the modulus of x plus 3. And if you notice, when the graph comes to this point here, instead of allowing the graph to continue on down into its natural progression, the modulus insists that y can never be negative. And all down here, y is negative. So it actually prevents the graph, the modulus prevents the graph from continuing down into the negative region. So everything that should have been a negative result here is flipped and made positive. So you see the graph bouncing back up again. Okay, so that's why you get that very unusual shape. So that's your graph. Now the next part is using your graph, write down the solution set to the inequality f of x is less than or equal to g of x. So f of x, oh, why that line keeps bouncing in there, is less than or equal to g of x. What do they want to know? They want to know where it happens that modulus of x plus 3 is less than or equal to 4. Remember, that's f of x, and that's g of x. So they said as well, use your graph. So let's have a look at the graph. So you see here the line y is equal to 4. That's the horizontal, thick horizontal black line. And the v graph is your f of x. And the question is, where on that graph is the v graph, the f of x, less than g of x? Well, of course, it's here. Down here. See it here? It's under it here. It's less than it. All of the y values here are less than all of those above. So that means it's, I'll change the pen color. Make it clearer. So in this interval here, it is the case that f of x is less than g of x, because it's under the line, so it's a lot lower than it. So what are those values of those intervals, the x values? Because when they're asking for a solution set, they're asking for the solution set in terms of x. So we have -7 is the first interval, and the other interval is +1. So x is somewhere between those. So that means x is greater than or equal to -7, and it's also less than or equal to 1. Actually, I'm just thinking, would it be, yeah, less than or equal to, that's right. I was about to think, should it only be less than? But no, the question is, where is it less than or equal to? So between -7, where x is -7, and where x is 1, the graph of f of x is less than the graph of g of x. Now, they want us to verify your answer algebraically. So algebraically, let's do it. So f of x less than or equal to g of x. That's the modulus of x plus 3 is less than or equal to 4. The way to get rid of the modulus is to square both sides, because by squaring it, you're ensuring that whether it had a negative value or a positive value, by squaring it, you were always going to get a positive value. So you haven't, because we could, if you just took away the modulus sign, you don't know whether there would have been a negative value inside there. So you can't be sure that you're maintaining the integrity of the equation. So the squaring is the safest way to do it. So if you square both sides, you x plus 3 ought to be squared, less than or equal to 4 squared. So we have x squared plus 6x plus 9 is less than or equal to 16. X squared plus 6x, bring over the 16, plus 9 minus 16 is less than or equal to 0. X squared plus 6x minus 7. And for this purposes, we've got it equal to 0 in order for it to find the solution set. So the solution set for this is x plus 7 minus 1. So for the first bracket, we have x plus 7 is equal to 0. So x is equal to minus 7. We have x minus 1 is equal to 0 for the second bracket. And the solution there is x equal to 1. You see, we found the same solution set. That f of x is less than g of x, less than or equal to g of x, between the values of x is equal to minus 7 and x is equal to 1. So again, you write your solution set like this. You always read it from the middle. I always do. I always read it from the middle. X is greater than or equal to minus 7, and x is less than or equal to 1. There's your answer. We have a cubic equation, has one integer root and two non-real roots. Find the three roots of the equation. We have x cubed minus 7x squared plus 17x minus 15. So when they say non-real roots, they mean complex roots. And complex roots always appear in pairs. So you'd have a complex conjugate pair of complex numbers. So the first way to solve this is you have to guess what the first, you have to guess what the first root is going to be. So what we do is usually we start testing x is equal to 0, x is equal to 1, or well, obviously not x equal to 0. Sorry, there's a pen here. So the first one that I would normally test is x is equal to 1. So that would give you 1 cubed minus 7 by 1 squared plus 17 by 1 minus 15. So that gives us 1 minus 7 plus 17 minus 15. And that is not equal to 0. So we try another one. X is equal to 2. So we have 2 cubed minus 7 times 2 squared plus 17 by 2 minus 15. So that's 2 squared, 8 minus 8 plus 34 minus 15. So you can see by that, not equal to 0. So you try 3. And this is literally what you have to do in your exam. So we try 3 and we get 27 minus 63 plus 51 minus 15. Yes, it is equal to 0, which means that x equals 3 is a root of the equation. Now it wants us to find the other two roots. But if we have the root x is equal to 3, then it follows that x minus 3 is the factor. So it's a factor of this equation. We'll move up here where we have more room. So the simplest way to find out what the other two roots are is to divide it in. Take it up here where it's more room. So x minus 3, we'll divide it in 2. X cubed minus 7x squared plus 17x minus 15. Right, so step by step, x into x cubed goes x squared times, multiply it back, so that gives you x cubed minus 3x squared. Change the sign to minus, change the sign to plus, that's gone. So we have minus 7x squared plus 3x squared, will give us minus 4x squared. Carry down the x, so that's plus 17x. Again, x into minus 4x squared goes minus 4x times. Multiply it back in, minus 4x squared plus 12x. We will have to change the sign here, change that to minus, so that's cancelling. And we have 17x minus 12x will give us 5x. Bring down our 15, get minus 15. Again, we divide in, x goes into 5x times 5 times. Multiply it back across, 5x minus 15. There we go. You have no remainder, which is what you would expect if x minus 3 was a factor. So what are you left with? You're now left with that x minus 3 by x squared minus 4x plus 5. If you multiply them together, that will give you x cubed minus 7x squared plus 17x minus 15. You still have to find the other two roots of x squared minus 4x plus 5. Now, they've already said to you that they're non-real roots, which means they're complex. which means you're going to have to solve it using your b squared formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. That's equal to plus 4. I'm just going to highlight here as well. What's your a? A is the coefficient of x squared, so it's equal to 1. What's your b? B is the coefficient of x, so it's minus 4. Don't forget the sign before it. And c is your constant, which is equal to 5. So substitute those into the formula and we get plus 4 plus or minus the square root of 16 minus 4 times 5 all over 2a. And that's equal to 4 plus or minus the square root of minus 4 all over 2. Now the square root of minus 4 can be written as, I'm just taking a side over here, okay? The square root of minus 4 can be written as the square root of minus 1 by 4, which can also be written as the square root of minus 1 by the square root of 4. And the square root of 4 is 2. So we have 4 plus or minus, and we know, sorry, go back over to the left side here. We also know that the square root of minus 1 is I. For those of you who haven't done complex numbers yet, you will come across it. You can't have the square root of a negative number. So what has been introduced is something that's called complex numbers. So the square root of minus 1 is I. So what we have here then is the square root of 4 plus or minus 2i all over 2. So we get 2 here. So the answer is 2 plus or minus I. And you see the way it's plus or minus? Because one value is 2 plus I, and the other value is 2 minus I. And they're the other two roots of the equation. So let me highlight that in red. Sorry. The first root that you found was here, x equal to 3, and the other two roots you found are down here. So that's 2, and that's 3. There are your steps again. You have to estimate what the root is. Usually, they don't normally take you past 3 or 4. So you test it like that. See which one is the root. Once you find the root, you then generate the factor. You divide the factor into the equation. That gives you the remaining x quadratic, and then you factorize that, and that will generate your either real roots or non-real roots. So our next part of the question is solve for x, where x is an element of a natural numbers. The square root of 3x minus 5 minus 3 is equal to the square root of x minus 6. So we have to be careful here. I'm just going to change my ink color back to black. So what you have to be careful here is square root of 3x minus 5 is an element, a separate element to minus 3. And what we have to do in equations where there's a square root is we have to square both sides in order to try and eliminate the square root sign. So if we square both sides, it's going to give us, on one side, it's going to be the square root of 3x minus 5 minus 3 by the square root of 3x minus 5 minus 3, and that's equal to the square root of x minus 6, all to be squared. Right. What you have to be careful of here is the square root of 3x minus 5 is an element, so we call it a, and the minus 3 is b. And here again, you've got a, b. So you're effectively doing a minus b to be squared, where a is equal to the square root of 3x minus 5, and b is equal to 3. Okay, so you have to be careful with that. So when we multiply them out, we will get square root of 3x minus 5 by, actually, I should move down a bit here. Some more space. So we have this is multiplied by this, and then this is multiplied by this. So we have the square root of 3x minus 5 by the square root of 3x minus 5 minus 3 times the square root of 3x minus 5 minus 3 times the square root of 3x minus 5 minus 3 by minus 3. So here we have square root by square root cancels the square root. The square roots cancel. So that gives us 3x minus 5. For these two here, we have 3 times the square root minus 3 times the square root gives us minus 6 times the square root. And we have plus 9. And that's equal to x minus 6, because up here, the square root of x minus 6 by the square root of x minus 6, excuse me, is x minus 6. Again, square roots cancel. So what do we have here? We have, again, if you look at this equation here, we still have the square root in the equation. So we're going to have to do some squaring again. The simplest way for squaring is to ensure that you just have a square root on its own on one side of the equation. It's much simpler than getting into this. We didn't have any choice in the other one because there was a square root on both sides of the line. But at this side, so what I would do is I would move the 6 times 3x, the square root of 3x minus 5 to one side. So let's move that over to one side. So we move it across to the other side. That's the square root of 3x minus 5 is equal to 3x minus 5 plus 9 minus x plus 6, which is equal to 2x plus 10. And if we divide across, so that's 6 times square root of 3x minus 5. So we have 2 as common denominator there, so that will give us 3 times square root of 3x minus 5 is equal to x plus 5. Now we're going to square both sides. It's much easier. So it's going to give us 9 times 3x minus 5 is equal to x squared plus 10x plus 25. That's going to give us 27x minus 45 minus x squared minus 10x minus 25 is equal to 0. That gives us minus x squared plus 17x minus 70 equal to 0. Multiply across by minus 1. We have x squared minus 17x plus 70 is equal to 0. So we need to solve this. We have x, we have minus 10, and we have minus 7. So the first bracket will give us x minus 10 is equal to 0, x is equal to 10, excuse me. Second bracket, x minus 7 equals 0, x is equal to 7. Is your solution. That's it. But the key thing in that question is when you have square roots in the equation, you need to square the equations both sides in order to eliminate the square root. However, in this question, it was tricky, first of all, by the fact that they have a square root and a minus 3 attached to it. It made the multiplication, the squaring, more tricky. And it also was tricky in that when you got to this stage, you had to do another step of squaring both sides in order to get rid of the square root, because it wasn't eliminated in the first run. But if you take your time, do it step by step, the place where you would fall down in this question is whereby you'd get mixed up. You'd make a mistake in the signs from positive to negative, and you'd make a mistake in writing down the numbers 3x minus 5. So it's in a question like this, you need to slow down, take it really carefully to make sure that your numbers are all correct. Here we do. Okay. So now we're into question 4, which is complex numbers. And for any of you that don't know, I is equal to the square root of minus 1, and I squared is equal to minus 1. So we have to simplify I to the power of 57. So the easiest way to do this is, we know that I is the square root of minus 1. And if we had it to the power, we'll say if we have I to the power of 2, that would be the square root of minus 1 by the square root of minus 1. That would give us minus 1. So if I did I to the power of 4, it would give me, again, square root of minus 1, square root of minus 1, square root of minus 1 by the square root of minus 1, and that would give me minus 1. So the trick here is that once you have a positive power, you are guaranteed that the square root sign will go. In this, we have an uneven power. So what we do is we break it up. So I to the power of 57 can also be written as I to the power of 56 by I, right? We know that I to any positive power, no matter what size the power is, will always give us minus 1. And I is the square root of minus 1. So we have minus 1 times I. Sorry, I made a mistake here. Jumped ahead a couple of steps. My own head. Okay, so we have I to the power of 56 by I. But we can also break I to the power of 56 up into I squared to the power of 28. Okay. And that's still by I. And I squared we know is minus 1, and still by I. And that's equal to apologies. Minus 1 by I minus 1 to the power of 28 by I is equal to 1 by I. Okay, let me go back a step to explain what I did. So I to the power of 56 I rewrote it as I squared to the power of 28. I squared is -1. So you put -1 into that bracket, and it's the power of 28. And we know that a negative number that's multiplied by itself even number of times will become positive. For instance, -1 by -1 is equal to 1. So that's -1 squared is equal to 1. So -1 to the power of 20 is equal to 1. So we have -1 to the power of 28 is going to be 1 by I, and that the answer is I. So the solution to this simplification is I. Right? The complex number Z is equal to 5 plus 3I, where I squared is equal to -1. Find the complex number W is equal to A plus BI, such that Z by W is equal to 2 minus 26I. So they've given you the complex number, and they want you to find the complex number W. So ZW here, we know what Z is. 5 plus 3I. We know what W is. It's A plus BI. So ZW is equal to 5 plus 3I by A plus BI. Multiply those out, you get 5A plus 5BI plus 3AI plus 3BI squared, and that's equal to 2 minus 26I. They're telling us up here. So if you look at these two here, 5BI plus 3AI, common denominator there is I. And 5A here and 3BI squared here are actually real numbers, because 3BI squared, we know I squared is equal to -1. So let's jiggle it around a bit. So that is 5A minus 3B plus 5BI plus 3AI is equal to 2 minus 26I. So here we have the real numbers and the imaginary numbers. So this is the real part, and this is the imaginary part. And we know that if a number such as this, with a real part and imaginary part, is equal to another number which has a real part and imaginary part, we know that the real has to equal the real, and the imaginary has to equal the imaginary. That being the case, 5A minus 3B has to be equal to 2. And if we rewrite the 5BI, let's see here, 5BI plus 3AI is equal to minus 26I. Knock out the i's. So you've got 5B plus 3A is equal to minus 26. So now you've generated two equations in two variables, which you could solve back at JuniorCert. Okay, so there's your 1, there's your 2. So I'm not going to do that now because it's very straightforward, but your answer is, if you're going back over on this video, the answer that you should be matching up to is that A is equal to -2 and B is equal to -4. And we go back up to W, which is W is equal to A plus BI, which means that W is equal to -2 minus 4I. And that's your answer. We have part C of question 4. which is the complex number W is equal to -2 minus 2 root 3i, write W in polar form. So polar form, so the form that you're looking at the moment is what's called rectangular form. And they want you to change it over to polar form. So polar form, what it looks like is Z is equal to R times cos of theta plus I sine theta. And that's based on the location of a complex number in on the Argand diagram. So this is Argand diagram, and we have -2 minus 2 root 3, so it's probably there. So that's -2 minus 2 root 3. That's that point. And the angle that that makes with the axis is theta. And R is the distance from the origin right out to that point. It's also called the modulus. That's where that comes from. So you're looking for R and you're looking for theta. So R is known by the square root of a squared plus b squared. And theta is solved by getting the inverse tan of b over a. For instance, if you have a triangle like this, and you have theta, R would be the equivalent of your hypotenuse. A, like that. So the tan of theta would be b over a. So theta is the inverse tan of b over a. So you would have learned, if you've studied complex numbers, you'd know these already. These are your key components. So to solve for R first, we're going to do R is equal to the square root of -2 squared plus -2 root 3 squared, which is equal to the square root of 4 plus 12, and that's equal to 4. Theta is equal to the inverse tan of 2 root 3 minus 2 root 3 over -2. And that's equal to the inverse tan of root 3, which is 60 degrees. Okay. So it's telling you that here you have this angle here with the axis is 60 degrees. But the angle related to this complex number is 240. So your polar form is Z is equal to 4 times the cos of 240 plus I sine 240. Here's your answer in polar form. Anybody not sure about anything in that, please put a question into the chat. So the next part of the question is, using de Moivre's theorem, solve the equation Z to the power of 4 is equal to -2 minus 2 root 3i. And any of you that have studied complex numbers will remember, or should remember, that de Moivre's theorem is handy in the sense that if we have a complex number, say for instance R times cos theta plus I sine theta. And we raise it to a power, maybe 7. Okay? That would be very hard to, now, that would be a very hard to multiply out and to solve. De Moivre's theorem helps us by that equates to r to the power of 7 times cos of 7 times theta plus I times the sine of 7 theta. With De Moivre's theorem, you can multiply the power by the angle, and then you go and solve that. So that's just a very brief explanation of De Moivre's theorem and how handy it is for solving complex number questions. So I'm going to remove that so that I can have space for the question solution. Right, so we know that, so this is it in a rectangular form, but De Moivre's theorem only works with polar form. So we have to convert this to polar form, which we have already done in this part of the question. So we know that z to the power of 4 is equal to 4 times the cos of 240 plus I sine 240, right? And to get z, we'd have to get the cubed root. So we'd have to get, or the quarter root. So that would be 4 to the power of a quarter. To go from that to that, you have to get the quarter root. 4 to the power of a quarter by cos of 240 plus I sine 240 raised to the power of a quarter. Using De Moivre's theorem, we can multiply that power in. So 4 to the power of a quarter is 2 times cos of 240 over 4 plus I sine 240 over 4, which is equal to 2 times cos of 60. Now, we have to do the general form. 60 plus 90. Actually, I skipped a step to explain the general form. Yeah. So the general polar form is 240 plus 360 times n. I'll explain that now in a moment. Plus I sine 240 plus 360 n. So the 360 n is to take into account the fact that you could have a complex number here. This is the angle. But if you go around the diagram once, it's 360 degrees. If you go around it twice, it's 720 degrees. You go around it 3 times, and so forth. So you don't necessarily know how many times round it has been or needs to be. So for the general form, you have to include n to represent the amount of times you have to spin 360 around the diagram. Tidy it up right here. So the 360n is adding on however many times you go around the diagram. Okay, so that's for the general format, and n represents the amount of spins around. So that means we have 360n divided by 4 plus I has room. So for multiplying everything in the bracket or dividing everything by 4, it's 240 divided by 4 plus 360n divided by 4 plus I sine 240 divided by 4 plus 360n divided by 4. That gives us 2 times cos of 60 plus 90n plus I sine 60 plus 90n. So what we need to do now is we need to give values to n. So in the first option, for n is equal to 0, we would have z is equal to the square root of cos of 60 plus 0 plus I sine 60 plus 0. For n is equal to 1, we have z is equal to square root of 2 times cos of 60 plus 90, which is 150, plus I sine 150. For n is equal to 2, z is equal to the square root of cos of 60 plus 180. So that's cos of 240 plus I sine 240. And for n is equal to 3, we have the square root of 2 times the cos of 60 plus 270, which is 330, plus I sine 330. And you solve each of those, evaluate them in your calculator, and you get, for n is equal to 0, you get the square root of 2 over 2 plus square root of 6 over 2i. For n is equal to 1, you get minus root 6 all over 2 plus root 2 over 2i. For n is equal to 2, you get minus root 2 over 2 minus root 6 over 2i. And for n is equal to 3, you get root 6 over 2 minus root 2 over 2i. So there are your 4 solutions. Some of you might say, how do you know when to stop with the n's? Well, you're solving for z to the power of 4, so you're going to have 4 solutions to that. Typically, if you have a quadratic equation, you have 2 solutions. If you have a cubic equation, you have 3 solutions. If you have z to the power of 4, you have 4 solutions. If, for instance, you had z to the power of 7, well, you would go up to n is equal to 6, because remember, you start with n is equal to 0, then n is equal to 1, n is equal to 2, and you go up. And that's how you know the number of times you have to use n. So that's using De Moivre's theorem to solve that and evaluate all of those. So your answers are solved and you get a rectangular form in your answer. The next part, we're on to our functions. Question 5. So the graph of the cubic function f of x is shown. Which graph below represents f prime of x, the first derivative of f of x? Justify your choice. Okay, so we've got a calculus question here. And f prime of x is the same as the derivative of x, which is also dy dx. So the equation, the function that you're given is a cubic function here. And the derivative is one of these three here. We want to know which one it is. So the first thing we'll start to do is take a look at the cubic function and understand what's happening there. So we have, I'll change to red here. So we have on the cubic function what looks to be a maximum and a minimum. We have a relative maximum and a relative minimum. So this point here is our relative maximum. At this point here is our relative minimum. And remember, the derivative of a function is finding the slope of the line, the slope of the tangent to that function. For instance, if we have a circle and we have a tangent to it, the derivative, if you derived that circle, what you're finding is the slope of the tangent at that point. At a point down here, the slope is different. The tangent is there. At a point here, the slope is different, right? So we know that the derivative of a function gives us the slope of the tangent at that point. What do we know about the slope? We know that at the maximum or minimum, at max or minimum, slope is equal to 0. So that would be the tangent to the point there. That would be the tangent to the point there. And we know at these points, slope is equal to 0. So the quadratic function that gives the slope of the tangent lines, it must have a function value of 0 at these x values. So remember, when you derive, if you get the derivative of a cube, let's say x cubed plus 3x squared, okay? If you get the derivative of that, that would give you 2x squared plus 6x dot, 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 okay? But what you've generated is a quadratic function. So when you derive this cubic function, you're going to generate a quadratic function, and a quadratic function either looks like this or looks like this. Okay? So it's a parabola. It's either U shape or N shape. And we know that the quadratic function that gives the slope of the tangent lines, it must have a value of 0 at these x values. These points here. Okay? So what at these points here, what do we know? Y is equal to 0 at these points. So we know that the quadratic, that the parabola crosses the x-axis at these points. So look at this one here. Is it crossing at those points? No. look at this one here. Is it crossing at those points? It's not crossing at all. It's not crossing the x-axis at all. Definitely not that. But look, here we go at this point here. It is crossing. The parabola is crossing at those points. And that's how you know. Now, they could make it really, that's an easy one to pick out. They could make it difficult by giving you the very same crossing lines. Could do it that way, give you an N. All right, this is a more, so what if they gave you two that look like that? So you have two of them that are crossing, that are crossing at the exact points. And you're thinking, oh God, how do I know which one is which? Okay, well, it's got to do with increasing and decreasing slopes. So if you have a look at this side of the cubic function, as it approaches this interval here, so as it approaches this point, it's increasing. It's an increasing function. And as it approaches this point, sorry, it's a decreasing, yeah, it has a positive function value. But it's decreasing between the points of the interval. And it's increasing on this side. Okay? So you have a positive change in the slope of the function on this side as it approaches that point. So coming in from here, it has a positive approach. And there we go. We see a positive approach outside this interval. Okay, and the same on the opposite side of this one. So that's the way to know. There's two ways to know there. First of all, the slope of the tangent at the points max and minimum. At the max and min, slope is 0, and at those x values, at those points on the x-axis, y is equal to 0. So you can establish the interval point, the points at which the quadratic, which is the derivative, crosses the x-axis. So it takes a bit of time to absorb it and to understand. And the second way to know is to do with the approaching, the value, the positive and negative value of the slope of the function as it approaches the interval. So if you have any questions, come back to me and I'll go back over that slide again. So your answer is this one. Primarily because it crosses at those 2 points. But at a more advanced level because of the positive increase of the slope as it approaches that interval. Okay. So move on. So we have a function here, y is equal to x squared times the cos of 4 over x. Find dy dx. Just change my pen color. So this is a very common question. What you've got to be careful of here is that there are 2 rules involved in solving it. You have a function there of x multiplied by a function of x. So you have to use the product rule. That's in your tables. And the product rule is dy dx is equal to u times dv dx plus v times du dx, where one function is u and the other function is v. But also within that, you have cos of 4 over x. And that's a function, the x, within a function, which is the cos. So you would be using the chain rule for that. That's just something to note. Product rule, chain rule. To begin, we will let u equals x squared. So du dx is equal to 2x. The next one we'll let v equals cos of 4 by x to the minus 1. Why did I write it as 4 by x to the power of minus 1? But this is what's really important. For derivatives, for differentiation, it all deals in powers. So you need to have every number written as a power. So 1 over x can also be written as x to the power of minus 1. So du dx is equal to, so actually I'll take this down the next line because this is important. So if v is equal to the cos of 4 by x to the power of minus 1, dv dx, so chain rule, you differentiate the whole outside function first. So what's the derivative of a cos function? It's minus sine of whatever is in the bracket stays there, it doesn't change, multiplied by the derivative of what's inside the bracket. So what's the derivative of 4 by x to the power of minus 1? It's minus 4x to the power of minus 2. Okay, which is equal to minus 4 by minus sine is going to give us plus. So that'll be 4 sine of 4x to the minus 1 all over x squared. Because remember, x to the minus 2 can now be written as 1 over x squared. So dy dx is equal to our product rule, u times dv dx. So that's going to be x squared times dv dx, which is 4 sine of 4 over x. I would differentiate it now so I can write it back the way it was, over x squared, plus v times, which is cos of 4 over x by v times dv dx, which is by 2x. So the x squareds cancel there, and our answer is 4 times the sine of 4 over x plus 2x times the cos of 4x. That is your answer. Now, a very common question that you're asked to do is differentiate from first principles, and that is very similar to the induction question, that you should have something like this memorized, and the minute you get this question, you do it straight away. It's very simple format. You follow simple steps, no matter what they give you in the function, it's straightforward. So to differentiate from first principles, we say f of x is equal to x squared plus 3x plus 5. Now we do f of x plus h. Wherever there's an x, we put in an x plus h. So it's x plus h squared plus 3 times x plus h plus 5. We tidy it up, we get x squared plus 2xh plus h squared plus 3x plus 3h plus 5. So that's step 1. That's step 2. And step 3 is f of x plus h minus f of x is going to be equal to x squared plus 2 hx plus 3x plus h squared plus 3h plus 5, and it's minus x squared minus 3x minus 5. That cancels with that, the 3x cancels with that, the 5 cancels with that, and we are left with 2xh plus h squared plus 3h. And fourth step is f of x plus h minus f of x all over h is equal to 2xh plus h squared plus 3h all over h. Cancel our h's, h, there and there. So it's equal to 2x plus h plus 3. Now for differentiation, which is the limit of, so the limit as h approaches 0 of f of x plus h minus f of x all over h is equal to the limit as h approaches 0 of 2x plus h plus 3. But it makes sense. If h approaches 0, well, and that goes to 0, so the answer is going to be 2x isn't affected by h, and 3 is a constant. It's not affected by h. So your answer is going to be 2x plus 3. And if you were to go back up and differentiate x squared plus 3x plus 5 by your conventional method, dy dx, you get 2x plus 3. That's how you just check yourself. All right, so that's one very like induction. There are a few steps. You just follow the steps, you substitute in the values, and deliver the answer. And you get, let me see, how many marks did you get for that? Could get 10 marks for that. So next one we have is question 6, which is integration. And they want us to integrate x squared plus e to the power of 3x plus 2 times dx. So one thing to remember about integration is you can integrate each one individually. So you could always write that as the integral of x squared plus the integral of e to the 3x plus the integral of 2 all dx if you wanted to. So that's equal to, what's the integral of x squared? So what do we do with when we're integrating? We increase the power by 1, so it goes to 3, and we divide by that same power. Next thing, we have e to the power of 3x. So if we differentiate e to the power of 3x, we would get e to the power of, so let's have a look. So if we were to differentiate e to the power of 3x, these are quick ways to remember it, dx, you'd get e to the power of 3x by 3, which is the derivative of the 3x. So it would be 3e 3x. So integration is the reverse. So it's e to the power of 3x, but instead of multiplying by the derivative or the integral of that, you divide by it. Okay? And 2, again, you increase the power. So 2 in theory is multiplied by 2x to the power of 0. I mean, x to the power of 0 is 1. Anything to the power of 0, e to the power of 0 is 1, x to the power of 0 is 1. So you increase the power, so it's by x to the power of 1. And don't forget plus c. Why? How do you know when sometimes you use c and sometimes you don't? Well, sometimes they give you the integral like that, and sometimes they give you the integral with pi and 0 on it. In other words, they're asking you to evaluate it between 2 points. So if you have a function that looks like that, and pi is here, and zeros here. They're giving you the limits of the integral. They want you to evaluate it between those points. Okay. So if they don't give you the limits, you have to include C. And yeah, they're fairly harsh in terms of if you don't put in the C, you won't get the marks. You have to be careful there. So if there are no limits, use your C. And that's your answer. That's it. Straightforward. So the next one is we have to evaluate, but here we have limits. Again, the limits are pi and 0. So you have to evaluate it for integrate it first, and then you use the limits. So something I just want to remind you, we have two functions here to integrate, sine and cos. So if you look at your tables, it will tell you that the integral of sine of ax, in other words, if there's a coefficient of the x, the integral is -1 over a times cos of ax. And the integral of cos of ax is equal to 1 over a times sine of ax. And what you're looking at here with your sine of 2x and your cos of 2x, your a there is going to be 2. So we'll do our integral here, pi to 0 of 3 sine. I like to do them separately. It's cleaner. You can do them separately. That can also be, you can always put a constant outside of the integral. Remember that is sine of 2x. And we know that that's going to be 3 times, and it's for the sine, it's going to be -1 over 2 times the cos of 2x. That's the first one. The next one is going to be -4 cos of 2x. That can be written as -4. Take it outside the interval. You don't need it. -4 times the cos of 2x. And we know that that is -4 times, back up here to our cos, and it's going to be 1 over 2 sine of 2x. Right? So I included the -4 in here. So when you put them back together, the integral is equal to, the answer is equal to 3 times. So 3 by -1/2 here, if we do 3 by -1/2, it's going to be -3 over 2 times cos of 2x minus 4 over 2 times here. It's going to be 2 minus 2 times sine of 2x. And we just put at the, once we have them integrated, we no longer use the integral sign. We have pi over 0 here. So the next step we have to do is we have to substitute in the value for pi across the whole answer, and then substitute the value for 0 and subtract them. So it's going to be -3 over 2 times cos of 2 pi minus 2 times the sine of 2 pi minus -3 over 2 times the cos of 0 minus 2 times the sine of 0, right? So, that gives us minus cos of 2 pi is equal to I cos of 0 is equal to 1, sine of 0 is 0, sine of 2 pi is 0, cos of 2 pi is 1. So I'm left with 0 minus 0 plus 3 over 2. And that's my answer. Is 3 over 2. Okay, I hope I can evaluate it correctly. You can check them anyway yourselves. But that's minus 3 over 2, minus 3 over 2, plus 3 over 2, 0. Yeah. Okay, so you just substitute in your values for pi, you're substituting your values for 0 and subtract them. And that's how you use the limits. And that's why you don't need the C in this. So I would take it very carefully when I'm doing questions like this. I would evaluate each part carefully, separately, because it can get very messy, as you can see. And your examiner as well will find it very easy to track your work. So if, for instance, when you're bringing the answers down into this part here, if you make a mistake, he can see that you had the correct answer up here or up here. It's very clear. And you put it in. All right. That's now our next part is diagram shows the line y is equal to x plus 4 and the curve y is equal to 6x minus x squared. Find the coordinates of the intersection points of the curve and the line. So this is going back to your simultaneous equations in the past. That's what the whole purpose of simultaneous equations was. If you had two equations, two linear equations, and you would solve them simultaneously, the results you were getting were the points where the two lines crossed. Then you went on to do simultaneous equations using a linear equation, a quadratic equation, and what you had to do was use the substitution method, whereby you'd substitute in a value for x or y into the quadratic, and that way you'd get a solution for x. You get two values, and that would again tell you where the line crossed the quadratic function. And that's exactly what we're looking at here. So our first one here is okay. Let's space myself here to work this out. I've changed to red, so it'll be easier to so I put in the graph and I didn't seem to leave any space for solving it. So find the coordinates of the intersection points. So we have y is equal to x plus 4, and we have y is equal to 6x minus x squared. So another way to do it is, what I use is, rather than x substitution, I equate the two equations, because here you have y is equal to x plus 4 and y is equal to 6x minus x squared. So if that's y and that's y, well then it follows that 6x minus x squared is also equal to x plus 4. And that leaves us with x plus 4 minus 6x plus x squared is equal to 0. And that gives us a quadratic x squared minus 5x plus 4 is equal to 0. And if we solve that simply, we get x has to be a minus, and we get 4, and we get 1. So that tells us that x is equal to 4, and x is equal to 1. So it means that this point here has to be 4, and this point here has to be 1. That's basically what we're looking at. So you equate the two functions, and the solution to that are the 2 points where they intersect. So you go a bit further, because actually we've got to be careful here. It asks for the coordinates of the intersection. It didn't say solve. So coordinates means we need an x and a y. So if x is equal to 4, we substitute it back in, and that will tell us that y is equal to 8. And if x is equal to 1, we get y is equal to 5. So this point here is, let's see, it's 4, 8, and this point here is 1 and 5. That makes sense. That's right. Well, hence or otherwise, find the area of the shaded region. So here's the hence question again. They're saying use the information that you've got. So for integration, what it does is it finds the area under the curve. If I have a function like that, and I integrate it, it gives me the area under that curve. But you remember when we were talking about the limits? I in 0. If I integrated it, it would give me a general solution plus c. But when you put in the limits, you're telling it, I want to know the area of under the curve between this point and this point. You could also do it this way. You could pick 2 limits here. Say if that was 2 and that was 4, replace that with 4 and that with 2. And you'd integrate again the function, but you would only substitute in the limits for 4. And it would literally tell you, it would literally calculate the area of that spot, the area under the curve. So integration gives you the area under the curve, which is why it comes up here in this question. But they've made it a little bit more complicated, because if we got, you've already identified points on the curve. But if we were to integrate this curve with the limits 4 and 1, it would give us all this area down here, right down to the, okay, which is no good to us. That's not what we're being asked for. They want us to evaluate the part with the grey in it. So what we do is we get the area under the whole curve between the points 1 and 4, and we also get the area under the line and subtract the area under the line from the area under the curve, and that means we're left with the area of the grey section. So that's basically what we're at when we have when we have 2 functions like that intersecting. Okay, so as I said, a straightforward one would be just to integrate the curve and get the area between the limits 4 and 1, but that's not enough. You also have to subtract the area under the line between those same limits and subtract it from it. We'll go about doing that now. So to get the area under the curve, you've got to integrate it first. So we have the integral between 4 and 1 of 6x minus x squared dx, which is equal to 6x becomes 6x squared. We increase the power and divide by that power. So it becomes 6x squared over 2 minus x squared goes to increase the power by 1, goes to x cubed, and then divide by that power, which is 3. And don't forget, we have our limits 4 and 1. So that's going to be equal to 6x squared is 3x squared minus x cubed over 3, 4, and 1. What do? We substitute in the values. So our first part would be 3 times 4 squared minus 4 cubed all over 3. That's the first part. That's the part with 4 in it. Minus 3 times 1 squared minus 1 cubed all over 3. That's the part with the 1 in it. And our value for that is 48 minus 64 over 3 minus 3 plus third. That's equal to 70 over 3. I actually think I got the numbers wrong on this, but anyway, 4, 16, 6, 48. Yeah. So the next part we do is evaluate the area under the line, which we know is x plus 4 dx. Excuse me, and that's equal to x goes to x squared divided by 2. 4 goes to 4x. And don't forget the limits, 4 and 1. So that's going to be 4 squared over 2 plus 16. That's the part with 4 in it, minus 1 squared over 2 plus 4, and that's the part with the 1 in it. And that gives us that 30. No. I have to excuse my values, guys, because I think I mixed up the values somewhere. I think I got for this, I got 16 over 2 plus 16 minus a half minus 4. That gave me 39 over 2. So your area of the gray part is equal to 72 over 24 minus 39 over 2. 39 over 2. 9 over 2. Now, I would put a question mark on these. I'm not sure if these numbers are correct, but I know that this is the answer. 9 over 2 is the correct answer. That I got somewhere. So 9 over 2 is the answer that you need to get to. So that's straightforward, okay? There's 2 steps in it. You get the area under the curve between the limits, 4 and 1. You get the area under the line between the same limits. Subtract one from the other, and you're left with the area of the gray region. So integration is very handy from that point of view for getting the area under the curve. How else would you get the area of it? Hence, oh dear. Same space left for both. Okay. Hence, right over there, we've done that. Right. So now we're moving on to section B, which is a shorter section, but the question marks seem to be a lot longer. The question marks are bigger and the questions seem to be longer. So we'll start with this one. So this is a typical exam question around logs. So you have a group of medical students in a certain university are studying the number of students on campus who begin showing flu-like symptoms during the month of January. The population of students displaying symptoms can be modeled using the function P of t is equal to AE to the power of BT. So that P of t represents population of students with symptoms, where A, B, and E are elements of the real, and T is time in weeks since the beginning of the study. On the first day of their study, 4 students were displaying flu symptoms. After 7 weeks, 23 students were displaying flu symptoms. Using the information above, show that A is 4 and B is 0.25, correct to 2 decimal places. Okay, so initially we look at our equation there, which is P of t is equal to AE the power of BT. And show that A is equal to 4 and B is equal to 0.25. So what do we know? On the first day, T has to be equal to 0 because it's the first day. There's no time has elapsed. T is equal to 0. So we know that P of T, population, is equal to 4. What about 7 weeks later? T is equal to what? Well, if you have a look, it's after, we've got time. T is time in weeks. So T is equal to 7. And we know that the population after 7 weeks is what? They told us 23 students were showing flu symptoms. So 23. So we substitute in 4, PT4, that's equal to AE to the power of 0 times T. Wrong. B 0. Okay, so here we have AEBT, and we know that T is equal to 0. So 4 is equal to AEB0. And that's equal to A times E to the power of 0. Anything to the power of 0 is 1, so that means equals to A. So there we go, 4 is equals to A. We've just shown that. Now let's do the 23. We know that 23 is equal to, we know A is 4, 4E, I have a ghost haunting my screen. Right, so we have 23 is equal to 4E 7B. All right. Can I go up here? Yeah, I can. 23 is equal to 4E to the power of 7B. Cross multiply down. So E to the power of 7B is equal to 23 over 4. Now we have a variable in a power. What do? We apply logs. So we get the log of both sides. So 7B is equal to ln of 23 over 4. Why did I pick ln? Because ln is equal to the log base E. And we're using E here, so we have to use ln. So you put that into your calculator. So B is equal to ln of 23 over 4 all over 7. And that gives you 0.25. And that's what we wanted to show. Okay, so we've solved for A and we've solved for B. Find the number of students who displayed flu symptoms after 15 weeks, correct to the nearest whole number. So let's put in here what we now know our values to be. So A is 4, E power of 0.25 T. That's our equation now because we solved for A and B. So find the number of students who displayed flu symptoms after 15 weeks, correct to the nearest whole number. So what's changed? 15 weeks, that means T is equal to 15. So we know that P of T, this is what we're trying to find, is equal to 4 times E to the power of 0.25 by 15. That's equal to 170. Just plug it in your calculator, right? But that's how many number of students have flu symptoms after 15 weeks. How many weeks did it take for 50 students to display flu symptoms, correct to the nearest whole number? So they're telling us that 50 students have displayed, so that is P of T, correct to the nearest whole number. How many weeks? They're asking how many weeks, so they're asking for t, solve for t. So we have 50, we know, is equal to 4 times e to the 0.25 t, and t is unknown. That's what we're trying to solve. So e for 0.25 t is equal to 50 over 4. We get again the log of both sides. So 0.25 t is equal to ln of 50 over 4. And t is equal to ln of 50 over 4 divided by 0.25, and that's equal to 10. So it took 10 weeks. Okay. Very clear what you're trying to solve for. Is it T? Is it P? Is it B? Or is it A? So draw a graph to show the number of students displaying flu-like symptoms for the first 5 weeks of the study. So it's like any equation that you have. P of T is equal to 4E 0.25 T. It's like any equation that you have that you want to solve, get values from it. So what about when x is equal to 0, or when, say, at the bottom here, draw a graph number of students. So this is time, and this is P of T. All right, number of students. So when T is equal to 0, we already know from previous question, when T was equal to 0, they told us on the first day of the study, 4 students had flu symptoms. So when T is equal to 0, P of T is equal to 4. What about when we had, what did I put in here? I put in 3. When T is equal to 3 weeks, we had P of T is equal to 8.5. We also did 10 weeks, 10 weeks with 50 students. So when T is equal to 10, we had P of T is equal to 50. What about 7? Is there 7 there? Yeah, 7 weeks gave us 23 students. So when T was equal to 7, P of T was equal to 23. So that's enough for us to start plotting. So at 0, we had 4. At 3, 1, 2, 3, we had 8.5. 8.5. Let's see. There. Actually, it was not quite 7 and 10 because there's no room for it on the graph. So what did I get? 4 solved. I got 4 is equal to 11. So T is equal to 4. P of T is equal to 11. 4, I have 11 there. 4 and 5, I got 14 there. Okay. See it there. My drawing is pretty bad, but it's a very gentle curve. Draw a graph showing the number of students displaying flu-like symptoms for the first 5 weeks of the study. All right. And that's it. That's the part of question 8. Okay. I mean, that question, people seem to be very afraid of it, but it's a very straightforward question. Just substituting in values. So now we have acceleration of a body can be represented by the function. So this has got to do with rates of change. This is our last question that we'll do. It won't take long, I'd say. Let's see. Okay. And again, it's a calculus question. So the acceleration of a body can be represented by the function a of t is equal to 4t minus 3 meters squared. Meters per second squared, sorry. Find the acceleration of the body after 5 seconds. So they've given you a formula for the acceleration of the body is a of t is equal to 4t minus 3. And they've asked for what is it after 5 seconds. So it's 4 by 5 minus 3 is equal to 20 minus 3 equal to 17 meters per second squared. All right? Find the speed of the body v of t at any time in the form v of t is equal to at squared plus bt plus c, where a, b are elements, are integers. Okay, so to find the speed of a body, this was the acceleration. So the acceleration is the derivative of the speed. So you've already, if you have the speed, if you have a function in terms of speed, say v is equal to 3t squared plus t. So that's speed. To get the acceleration, you get dv dt. Okay? And that will give you 6t plus 1. So I'm just explaining how you go from speed to acceleration. You have to differentiate. So it follows that they've given you, you know the acceleration, and now they want the speed, so you have to go backwards. And what do you do to go backwards? You integrate. So to go forwards, you're differentiating. To go backwards on your differentiation, back to what it was, you integrate. So you're going to integrate 4t minus 3, and that is equal to 4t squared divided by 2 minus 3t plus c is equal to 2t squared minus 3t plus c. Don't forget c, really important. Why? Because you have no limits. Look, no limits. And that's it. The acceleration of a body can be represented by this function. Question 9. Oh yeah, that's it. And now going on to question 3. Given that the body had a speed of 11 meters per second after 2 seconds, find the value of c. So what are they telling you? That the 2t squared minus 3t plus c. So we had 2t squared minus 3t plus c. So they're telling you that. So we know that a of t, no, v of t, is that. And they're saying, okay, well, we know that it had a speed of 11 after 2 seconds. Find the value of c. So what do? We, for t is equal to 2, substitute in 2 into 2 squared minus 3 times 2 plus c equals 11. So that's 4, 8 minus 6 plus c is equal to 11. So c is equal to 9. So the equation is 2t squared minus 3t plus 9. That's the equation for speed, or v of t. Okay, v stands for velocity. So given that at t is equal to 0, s is equal to 0. S is the, find the distance the body will travel in the first 3 seconds of motion. Okay. So again, going back to what I said to you, if I have s of t is equal to 3t squared plus 4t, that's for distance. Okay, if I differentiate that, it's equal to speed, and it gives me 3t plus 4. If I differentiate that, I get, that becomes v dv t. It gives me acceleration, and I get 3. So that was cubed, and that was squared, 3, 9, 9 squared, right? That'll be 18t. Okay, so the steps are, you have distance, you differentiate distance, and you get speed. You differentiate speed, and you get acceleration. Okay, so they've now said that given these values, t is equal to 0, s equal to 0, find the distance the body will travel in the first 3 seconds of motion. The key here is the distance. So now they're asking us to work out the distance. How do we work out the distance? Well, what we did in the last question, we had the acceleration and we integrated it to get the speed equation. Now we have the speed equation, we have to integrate it to get the distance equation. So what's our speed equation? It's 2t squared minus 3t plus 9 dt. We integrate that and we get 2t cubed all over 3 minus 3t squared all over 2 plus 9t. And they've given us a value at solve at t is equal to 3. What is the distance? So that gives us s of 3, because this is now s of t. Here's our distance equation. We've integrated back the speed to give us that. So s of 3 is going to be twice into 3 cubed all over 3 minus 3 times 3 squared all over 2 plus 9 by 2. And that gives us 31.5. Okay. The key there is integrating the speed to give us the distance. Yeah, so that's the end of that question. Question 9. Oh yeah, no, that's part B. Question 9. Okay, we're just on to the last part. It's still with me. We just have 2 parts to this. So we have this is rates of change. A spherical balloon is being inflated at a rate of 3 centimeter cubed per second. Find the rate of change of the radius of the balloon, which is dr dt, when r is equal to 3 centimeters, correct 2 decimal places. So let's concentrate on the first part. So the rate of change. They're asking for, asking for dr dt. That's what we need to find, dr dt. They've already given us, what's this? A rate of 3 centimeter cubed per second. What is that? Rate usually means with respect to time. Okay, so rate always means with respect to time, dt, and 3 centimeter cubed is with regard to volume. So it's the change in volume. So what you have here is dv dt is equal to 3. They've already given us that, right? And we need to find dr dt. So the volume of the sphere is 4 over 3 pi r cubed. If we were to differentiate that, because v is one variable and r is the other, it would give us dv dr, right? So that's going to be 3 by 4 over 3 times pi r squared. 3's cancel, so we're left with 4 pi r squared. Okay, now we have dv dr and we have dv dt. So let's put them together. So dr dt is equal to dr dv times dv dt. How do you know if that works? Well, look, you could cancel the dv's and you would be left with dr dt. You see that? That's how you know it works. And that's going to be equal to, we've already got the values for it. Now, see here we have dr dv, but what we've actually solved here is dv dr, but that's okay. If we turn that upside down, that becomes dr dv is equal to 1 over 4 pi r squared. So you can do that, you can flip them. So that gives you 1 over 4 pi r squared multiplied by the dv dt, which we were given at the beginning, is 3. So dr dt is equal to 3 over 4 what have I got? 4 pi r squared, which is equal to, remember, they've also given us when r is 3 centimeters. So that's equal to 3 over 4 pi 9, and that's equal to 0.03 centimeters per second. Okay, that's dr dt. So the next part of the question is, the last part is to find the rate of change of the surface area, and they're telling you that is dA dt when r is 3 centimeters. So it's dA dt. So what's it? Oh. Oh dear. I think I just lost all of them. Pointer pen. So they're asking for dA dt, right? That means you're differentiating the area of something with respect to time. So what's the area of a balloon? Well, it's 4 pi r squared. Now, it's A is one variable, R is the other. So dA dr is going to be 8 pi r, right? And what are they asking us for? They're looking for dA dt. So dA dt is equal to dA dr by dr dt. And we solved dr dt in the last question. So that's going to be dA dr is going to be 8 pi r multiplied by 3 over 4 pi r squared. And that is, I'm going to substitute in the r for the 3, so it's going to be 9. The pi will cancel, and we'll be left with 24r all over 4 is 36. And they have said to us when the radius is 3 centimeters. So when r is 3 centimeters, your answer is 2 centimeters squared per second. That can also be written as 2 centimeters squared by s to the power of -1. Okay, so that's the last question, the last one. So I hope you were able to follow it. I hope it helped in terms of your study. If you have any questions, please put them into the chat and I can answer them now. And best of luck in the rest of your exams, particularly for Christmas and also for the Leaving Cert. I'll hand you back over to Eamon.
Hello, everybody, and thank you, Suzanne, for a great presentation. Lots of questions there. Note for the students, if any of you have got a question for Suzanne, then it'll be a great time. Any questions from the presentation or anything at all, I suppose, that you think she might be able to answer? It's a great time. And if not, I think I'd like to just say thank you very much, Suzanne, for the presentation again. It was great, lots of questions. And this is the second last tutorial of the season. We're going to have one more tutorial this afternoon from 2:30 to 5 with Paul Sheehan doing the paper 2 exam questions. So hopefully we'll see you there for that. Okay, that's all. Bye for now.